All right. Well, I think we'll go ahead and get started. If people join us later, we are recording this, so people can join in later, and whatever they miss, they can watch at a later time. So, welcome everyone to our 2020 Waccamaw Data Conference. I know a lot of you have been to our normal, quote unquote, normal data conference where we meet in person, but in these strange and different times, we're going virtual. And we think that maybe more people will get to join us and learn a little bit about the Waccamaw River Volunteer Water Quality Monitoring Program and what so many of you are doing to help us keep our river clean and safe. So thanks for joining us. I'm Kara Schultnick. I'm your Waccamaw River Keeper and the field coordinator for the Waccamaw Volunteer Monitoring Program. And our co-presenter today is the Waccamaw Watershed Academy, and that is out of Coastal Carolina University. So let's go ahead and get started. First thing we wanted to let you know about, we've got a little bit of housekeeping type stuff. Y'all are going to be muted throughout while the presenters are speaking. However, when it's time to ask questions, if you want to ask questions, we can unmute you and you can ask your questions that way. You can also ask your questions through the chat, which you'll find down at the bottom where you see circled this image. Yep, right there. Thanks, Victoria. Victoria is my technical person today, which brings me to the next item. If you have questions, please call Victoria because I am Zoom illiterate for the most part and I won't be able to help you, but Victoria is awesome and she will be able to help you with any of that. Okay, go ahead, Victoria. So we're going to be meeting this morning from 10 until noon. Our agenda is tight, but I think we will be fine. We do have a break in the middle. We're going to go ahead and I'll introduce myself and some of our speakers, and then we'll go ahead and get on with the data presentation from Dr. Libes. But this is what we've got going on, and you'll see in the chat, Victoria is letting you know if you have questions, that is her number. All right. So I wanted to do a brief introduction of the Waccamaw Volunteer Water Quality Monitoring Program. I know that many of you are familiar with our program, but if you're not, we wanted to give a brief overview so you'll understand what we're actually going to be talking about today. So we have a program along the Waccamaw, all the way from Lake Waccamaw clear down to Winyah Bay. And there are 9 teams that sample all during the year. We have about 50 volunteers with these teams, and there are 18 sampling sites total. And y'all manage to collect over 400 water samples every year. This year might be a little bit different. Victoria and Kelly and I and Zach, our awesome, amazing grad student who is working with the lab, all kind of filled in and helped out. But we are so happy that you guys are back and in the field and doing the sampling. I miss being out on the river every week, but I'm glad to have you guys back. So this is a little bit about our program. Go ahead, Victoria. Thank you. And we just wanted to recognize how many moving parts there are with this team and how many different organizations are involved. We have local partners from the municipalities, local education partners, and then we get some different funding in North Carolina for our program. So we want to thank everybody who's involved, and also thank you volunteers for everything that you do. Yeah. So without further ado, we're going to move on a little bit quicker than we thought we were, which is good. We'll give Susan a couple more minutes to talk about data. You all probably know Dr. Susan Libes. She is the founding director of the Waccamaw Watershed Academy and Distinguished Professor Emeritus of Coastal Carolina University. And today she is going to be presenting recent results from the Waccamaw River Volunteer Monitoring Program and letting us know what's going on in the river. So with that, Susan, I'm gonna pass it over to you.
Hi, can everybody hear me?
Yes, we can hear you.
Okay, finally. I am going to go ahead and share my screen. Is that okay?
Yes, that's fine.
One last question. Can you see the slides?
Not yet. There, it might take a minute.
Not yet?
No. Did you click on the, it might have taken a second for me to give you permission. Do you see the green box or red box around your slides?
No. I see it around my picture.
So you click the green share screen button at the bottom,
I did.
and did it give you the which screen to choose?
Oh, there's another share button, a blue button now.
All right, we see the PowerPoint slides. All right.
Am I now in slide mode?
Correct, you are.
Very good. Okay. I certainly appreciate the few extra minutes. As usual, I've probably tried to stuff too much into this presentation, but I know many of you are quite anxious to hear about what your data are telling us. So I appreciate the opportunity. I'm going to try to do two things today. The first is present your data in terms of the impacts that flooding has been having on some of the trends that we watch. So I'll be going over your conductivity, dissolved oxygen, pH, nutrient, and a little bit about your E. coli data. And I promise I will say a few words about Lake Waccamaw as well. And I'm going to move over after that to some shorter term trends, the ones that emerge right after we've had a pretty significant rainfall, because it illustrates the roles that tributaries play in delivering polluted runoff into the Waccamaw River. So the major tributaries that play this role include Buck Creek, that's on the North and South Carolina state line near the Highway 9 site, Simpsons Creek, that's a bit upstream from Reeves Ferry, and Crabtree Canal, that's a bit upstream from our Conway sampling site. And in truth, that's why these sites were positioned where they are, to try to help us characterize what the impacts of these tributaries are. And this topic then leads into the special speaker of the day from the Army Corps of Engineers. Chrissa is going to be talking about some recent proposed efforts to try to do restoration and improve fish habitat, and in so doing, improve the water quality in Crabtree Canal. So with that, I'll go ahead and get started with the flooding. But let me just do one last check-in. Victoria, do the slides look okay?
Yes, they do.
Wonderful. So why are we talking about flooding? Well, the answer to this question is that recently we've had an increased frequency and intensity of floods. I'm going to show this for you with the hydrograph from the USGS that is based on 70 years of record of discharge that we have at a sensor positioned off the Highway 9 bridge over the Waccamaw River. The black line shows the normal discharge, the daily discharge in cubic feet per second. So there have been some periods of very high levels that I'm showing with these purple circles. Some of these have exceeded the former record highs for this site. That's being shown with the purple blue color, the percentile that represents 90 and above. The brown colors are the record lows. So we've had some record lows, most notably in the middle of 2019. These year numbers are positioned over summertime. Just about every one of these highs in daily discharge had as a consequence a flooding event, either a major or a moderate flooding event, and were the result of a hurricane. I'm sure many of you recognize these names. So this recent spate of increased frequency of floods started with Joaquin in 2015, Matthew in 2016. Irma was sort of a lesser event, but nonetheless was at the top end of the above normal, going into the much above normal range of the purple blue color. Followed by Florence, then Dorian. And in 2020, interestingly, we had a major flood event during the later part of the winter, early part of the summer, spring. And I'm going to focus in now on what caused that sort of unusual flood event. Fortunately, we haven't had a hurricane yet this year to produce flooding, but we did have that major event. What caused it? To understand that, we need to look at the rain data. What I'm showing you here is volunteer monitoring data from a sister program, the COCO-RAWS program that some of us participate in, where we read our rain gauges every morning. And the data for the past water year, October 2019, and I put in the October 2020 data over here, is being shown in cumulative monthly accumulations as these blue bars. The 30-year average, the 30-year average is being shown by these blue dots here. Every single month in this past water year, we have been above the 30-year average for rainfall. So what caused that major flood in the summer and the spring? We had a big winter storm that for that month delivered over 6 inches of rain. And then in May, we had a hurricane. Some of you may remember Bertha. In July, we had 2 hurricanes, Isaias in August and Sally in September, and then we had 2 in October. So we've had a lot of frequent rainfall events. None of them were significant enough to bring us back to the major flooding that we had in the late winter, early spring. But nonetheless, we've had an unusually rainy summer. So what impact has this increased frequency of flood events since about 2015 or so had on the water quality that we measure at our sampling sites? This is a map that just shows where our sites are in the main stem of the river. I had to cut off the Lake Waccamaw sites here, but they're up here towards the right of the slide. The first thing is we've experienced a pretty significant decline in conductivity. Remember, conductivity is a measure of the total dissolved solids that are mostly salts. The level of conductivity that we see in the river is nowhere near what you'd see in river water that can be upwards of 50,000. But nonetheless, we have detectable levels of conductivity that undergo big shifts. During the record drought that we had, that lasted, through the end of 2012, conductivity across all your sites in the main stem was around 113 with these weird units of microsiemens per centimeter. You can see all the sites that I commingled on this graph. After 2013, the drought ended and we started to see that increased frequency of hurricane and flood events, such that the median for conductivity dropped down to 90 microsiemens per centimeter. To give you a gut feeling of how much extra rainwater was in the system, that's about, making a couple of assumptions here in my calculation, that's about 20 parts of rainwater added to what was the normal river water prior to 2013. That's a lot of extra water that has been added to the system and is diluting the conductivity. So we've got lower total dissolved solids. That's a partial cause for a higher acidity level that we detect as a lower pH, and begs the question, well, who even cares? There's no water quality standard for conductivity, but we do know that lower conductivity and lower pH is an inhospitable condition for freshwater mussels. The Waccamaw River and Lake Waccamaw are pretty renowned for having a couple of endemic species of freshwater mussels. I've taken this entry up here on the slide from a guidance manual on freshwater mussels in South Carolina, and point out that besides the importance of preserving biological diversity, keeping freshwater mussels in the Waccamaw River and Lake Waccamaw is important for the ecosystem service that these filter feeders provide. The guidance manual had these really cool photographs in it that show if you have very turbid water, a lot of particles suspended in the water, that problem can be cleared out in just 15 minutes by a bunch of filter feeding by these mussels that were placed in the tank on the right-hand side. The tank on the left-hand side still looks cloudy. Some of the particles have settled, but it still looks cloudy. So we want to keep mussels in the system for this important ecosystem service. So it's a bit concerning that the conductivity levels have been on the decline. So that is the story with conductivity. The second impact that flooding has had is seen in the dissolved oxygen levels. we've been measuring oxygen with handheld meters when you're out there at the river, because the river naturally has low oxygen levels. For that reason, the DHEC approved in 1999 a special discharge plan called a total maximum daily load to make sure that dischargers of oxygen demanding substances do not exceed the assimilative capacity of the river and cause oxygen levels to drop even lower than they are right now. Why do we care about oxygen levels being really low? Well, fish and other animals require oxygen to survive, so we don't want to end up with a fish kill. The data that we're looking at here on the graph, I downloaded from our website that shows box plots for each one of the sites on the main stem of the river, starting from the north end in North Carolina at Babson's Landing and proceeding downstream along the river to the right-hand side where we have Hagley and Sandpit River. The boxes represent 50% of the data that have been collected since the start of the program in 2006. If any part of that box is sitting below this red line, there's a potential water quality standard. In the case of Sterrett Swamp, and I saw Dale was on the line there, this site, more than half, 50%, more than the median of your samples is sitting below that water quality standard. And for that reason, this site is on the list of impaired water bodies. Some of the other sites that have 25% or more of the samples lying below 4 include Conway and Pitch Landing and Bucksport and Peachtree. We're getting awful close with Enterprise, my site at Merle's Landing, and Reeves Ferry up here in North Carolina in Pireway. So we have a situation here where the TMDL, although approved in 1999, doesn't look like it has remedied the low oxygen levels at least some of these sites, where no more than 25% of the samples should be falling below the 4 milligram per liter level. Lake Waccamaw, you have 2 sites, Canal Cove and Big Creek. These sites are not in the lake proper, so it's not surprising that they also have very low levels of oxygen. So how does this relate back to our crabtree story? Well, some of the fish that we understand could be populating crabtree, especially if water quality improved in that tributary called Crabtree, have oxygen requirements above 4 milligrams per liter. So they include American shad and alewife. Here's the shellfish like clams. This is why that water quality standard of 4 milligrams per liter has been set. By the way, the rest of the state in the uplands, the streams, have a water quality standard of 5. Ours is set at a special low level in recognition that the river naturally has low levels of oxygen because of all the organic matter coming from the swamps that fuels natural bacterial respiration that removes the oxygen. What about trends over time in these oxygen levels? Have they been changing the way that we've seen conductivity as a result of flooding? To answer this question, I'm looking at your oxygen data as percent saturation of dissolved oxygen. As we've seen in the past, because of that natural bacterial removal of oxygen, your sites just about all of them on the main stem, have less than 100% saturation of oxygen. They're undersaturated. That oxygen deficiency is in large part, if not all, due to the natural removal from the bacteria. So the question is, has this changed over time? Looking out over the summers, we normally see low levels of oxygen. Anything less than 60% is considered to be stressful to fish. Hang on a minute, I got a cat problem. Sorry about that. So one of the reasons that I'm showing percent saturation of oxygen is because it removes the effect of temperature on the simple solubility of this gas. Any variation that we see over the summer with high values in the winter and low values in the summer, we can attribute to some kind of biological influence and to a minor extent, physical mixing. So normally we see low levels in the summer because of more biological bacterial respiration, and high levels in the winter. When it's cold, the bacteria slow down. After 2013, the dips down in the summertime seem to have gotten quite a bit lower than what was going on in the summers of 2013. What is the cause of those dips? Again, they coincide with all of those flood events driven by the hurricanes. The start of this in 2013 began with just a bunch of heavy rains that hit in the early summer that took a long time to recover from. And then Joaquin sent us way down, Matthew way down, Irma way down in saturation of oxygen. And finally, we got to record lows here with Florence. I'm zooming in on the Florence time to show you that we dropped down to 0 level of oxygen in the surface water. There were fish kills during this time, and it took many months for the oxygen levels to recover after that flood event. Remember that we had to take the volunteer monitoring program on hiatus during this period, mostly because our sampling sites were flooded. The only data we have in this period was from me, and I even was struggling. I had to take a canoe out to get these samples during this period, but everybody got back in action sort of late in October to record the oxygen recovery after Florence. And this was Dorian out here, where it took a while to recover from that one as well. So we've seen an increased oxygen deficiency as a result of the flooding. Part of the reason for that is when the water level rises in the river, it submerges vegetation, and after a period of submergence, that vegetation can't survive anymore. It dies off. The natural bacteria in the river are able to decompose all this fresh organic matter, and you end up with darker colored water, kind of like brewing a cup of really strong tea. All that organic matter gets dissolved, darkens up the water, and nitrogen and phosphorus are released as well. So one of the consequences of flooding is probably some kind of pulse delivery of organic matter, organic carbon, and nutrients. So to recap here on our flooding impacts, we've seen a trend in decreased conductivity over time, decreased oxygen during the summer flood events associated with the hurricanes, and most recently with some wintertime flooding. Both low conductivity and low oxygen contribute to lower pH, and we noted that was a concern to the freshwater mussels. Regarding the E. coli and the turbidity, we generally do not see trends there from the flooding because of the overwhelming diluting effect. These are influenced by human sources rather than the natural flood biogeochemistry of the river. So generally, the flooding acts to dilute these, but we certainly can see the impacts of humans on discharge of E. coli and turbidity when we look at shorter time scales, like after individual rain events. So that's what I'm going to move on to talk about. This is the second half, the last half of my talk. We'll come back again, look at our sampling sites, and now look at the impact of stormwater runoff that is delivered through 3 major tributaries that happen to be located upstream of the city of Conway, or one of them's around Conway. So we have 3 sampling sites in yellow: Highway 9 and Conway here. I think, gee, I forget now why I picked that one in yellow. Oh, Reeves Ferry, right. I'm going to be showing you some Reeves Ferry data. So why am I focusing on tributaries? The way that we have managed these tributaries by channelizing them over the decades has caused them to function a lot like a pipe, a point source discharge of water with concentrated level of pollutants. Once that discharge hits the river, it starts moving downstream. Let's say some of that discharge contains oxygen-demanding substances, like the organic matter in eroded sediment or septage from a septic tank. It begins impacting the river. The natural bacteria will decompose that oxygen-demanding material, and in doing so, cause the oxygen levels to go down. So you see something called a sag in the oxygen levels downstream of the impact. So this is what we want to look for in your data. Is there some kind of a sag? The tributaries are draining water out of fairly large watersheds. Buck Creek straddles the state line. Simpsons Creek is in between the other large watershed, Kingston Lake watershed, where Crabtree Canal is located. These areas have been the subject of pretty aggressive management since the 1960s. A state law was passed to set up watershed conservation districts that were meant at providing tools for flood control and soil erosion control. In other words, trying to impose some stormwater management on these systems. And at the request of the communities, the Army Corps of Engineers began channelizing these systems. By state law, these watersheds are managed by elected commissioners that are in tax districts. The property owners in around the creeks and canal are taxed to help pay, but that has since been taken over by Horry County because the needs kind of outstripped the source of money. So a quick tour of how massive these systems are. Here's Buck Creek. I've outlined the tributary in orange that starts with flows upstream of the state line, and moves water down into the floodplain, where it then travels downstream to our sampling site on Highway 9. Kingston Lake watershed is the only watershed on the river that has an urban center, and that's Conway. Snaking around it is the tributary that was a swamp, Crabtree Swamp. It was channelized starting in the 1960s by the Army Corps of Engineers, and is the subject of Chris's talk in just a few minutes. This is about 8 miles of tributary, a very large drainage system that snakes around the city. And zooming into the tributary here, highlighted again in magenta, all that flow of water that's draining the urbanized area discharges into the Waccamaw River, kind of like a point source that travels downstream to our sampling site at Conway. So the first thing I want to return to is conductivity. The tributaries naturally have high conductivity levels. I'm resorting to some data from the Environmental Quality Lab here to show you box plot wise that they're very high relative to the mainstream of the river. And the reason for that is the water table throughout Kingston Lake watershed and the other watersheds in the Waccamaw is really high. So if you cut a ditch and stick a pipe, you will get a dry weather flow that represents drainage of groundwater into the systems, Crabtree Canal. And for that reason, the creeks always and canal always have high conductivity levels compared to the river. I'm illustrating that here with conductivity data over time from the USGS sensors. This one at Highway 9 where we sample, after a rain event, you see very high levels of conductivity for a day or so. And these are 3 rain events that I've followed here. Moving downstream to Reeves Ferry, look at the little green line under here. A day or so later, we're picking up downstream movement of the conductivity. It's washed away from Highway 9, traveled downstream within about a day to Reeves Ferry. And then finally moving down to Conway, you'd think, oh, well, that level, by the time it gets down to Conway, should be similar or as low. But the blue line shows us that the conductivity is always higher at Conway than we would have predicted from the upstream flows from Reeves Ferry. And the reason for that is discharge out of Crabtree Canal of another slug of high conductivity water. So conductivity makes a really good tracer of the inputs of polluted runoff to the mainstream of the river. Here's an example of that, turbidity. So we're used to thinking of that as the cloudiness or the particle level in the river. Here's the USGS data, just zooming in on October 12th. This was one of the October hurricanes. I think this was Delta. So we saw high conductivity hit the river at Highway 9, and then a day later it travels down to Reeves Ferry. That's the green line. And finally, looking down at Conway, wow, look what Crabtree Canal did. It produced a higher discharge of turbidity into the river than we saw up at Buck Creek. And it took several days for things to wash out from Reeves Ferry and Highway 9, but we never saw the level of turbidity up at Conway return back to the baseline. We've caught rain events in your volunteer monitoring data that show the same thing. This is way back in 2015, where the impact of Buck Creek and Crabtree is seen in the two downstream sites, and there's Sterrett Swamp. The higher levels of turbidity down here at the southern sites are due to the influence of the PD merging in. And likewise with the E. coli, after a big rain event on the November 4th, 2015, we caught impacts to the E. coli. So this leaves us down to a discussion of what to do about Crabtree. We recognized back in the 1990s that special attention was required for the pollution problems in Crabtree. They've been on the federal list of impaired water bodies since 1996, and I think there was data in there to these former listings that go all the way back into the 1980s. The problems include not just fecal bacteria, but also low dissolved oxygen. So no one knew whether or not non-point sources were contributing, stormwater runoff was contributing to those low duration problems. And what I undertook starting in 1999 was a special study to identify whether pollutants were coming out of Crabtree or coming from upstream in Kingston Lake watershed. That was captured by having these two sampling sites positioned to isolate those sources. And then downstream here at a site that captured flows off of downtown Conway. And finally, this last site where we have continued the work through volunteer monitoring in the Conway area. We didn't need any fancy monitoring equipment to know there was a big bad problem with turbidity. This is what Crabtree sadly still looks like if you're pointed upstream from the Long Avenue Bridge. We are now capturing that with the turbidity sensor located on Long Avenue. So we had enough data from my study back in 1999 to 2002 to compute how many tons of sediment were moving out of Crabtree in the 24-hour period after a significant rainfall. Those sampling sites that I showed you, here's the Crabtree Canal site, the Kingston Lake Swamp site, and the main stem. Not much moving off of the urbanized downtown Conway. This tonnage, in most cases, was equivalent to a couple of dump trucks of dirt traveling down into the Waccamaw River every time it rained. So I was able to figure out with that amount of rainfall over the year, how many tons per year were moving into the river, and it is substantial. Where is this dirt coming from? Well, some of it was coming from construction sites, but the stormwater programs have done a good job here at cleaning that up. We're now focused on, and this is where the restoration is focused on, failures of drainage ditches. This is an example of one of many drainage ditches in the Crabtree system. Taking a look here at the map of the Kingston Lake watershed, again, all the blue lines are natural creeks that are collecting that sediment. The green line is Crabtree. And now what I'm going to show you is the ditch network that has increased the stream lines by a factor of 7 over the natural blue lines, and as a consequence helped contribute to stormwater stress on Crabtree that's leading to increased flows and bank failure, and the failure of the banks is contributing the sediment, tons and tons of which are moving into the main stem of the river, with every rain event. With that soil, that sediment, comes organic matter. I was able to compute how much organic oxygen demand that material represented on each individual storm. And it was 6 times higher than the wastewater treatment plants are permitted to discharge to the river as part of the TMDL plan. On an annual basis, this non-point source flow of oxygen demand was on the order of what we were permitting the Conway sewage treatment plant to discharge into the river. So this may be part of the reason why the oxygen levels in the river have remained so low despite having put a TMDL in place in 1999. The last problem that we were able to investigate was fecal bacteria. These bar graphs show the different kinds of bacteria we tracked: fecal coliforms, E. coli, and Enterococcus, all regulatory indicator bacteria, through the Kingston Lake watershed to try to identify how bad was the problem and where was it coming from. This is just showing storm event sampling. Virtually 100% of the time, some of these sites during 24 hours following a storm event had bacteria levels exceeding the regulatory criteria. Anything over 10% frequency represents an impairment. So I think we have identified a significant source of fecal bacteria to the river that needs to be cleaned up. The concentrations that we were detecting were hundreds of thousands and even millions. So this is a serious problem. Having concluded my research in 2002, I tried to get the city of Conway and Horry County interested in doing something about these findings. They were the very first data to show non-point sources were a big problem here in Crabtree and in the river itself. As a consequence, the EPA awarded us money to develop the first watershed plan, I think, that was developed in the state of South Carolina, and this was for Kingston Lake, that had as action items restoration of Crabtree. So that restoration work started in 2008 as we were developing the plan, partly because DHEC was able to begin the phase 2 stormwater program in Horry County with the city of Conway and the county personnel that included, by 2009, a new watershed manager, and Chelsea's playing that role today. Restoration work did proceed with various pots of money awarded from places like the Fish and Wildlife Service, to the point that EPA awarded Horry County in 2017 a Raincatcher Award for its restoration work. But you can see there's still lots left to do here, and Chrissa is going to talk to you about that. My apologies if I've run over here on time. I just wanted to do a good job in introducing why the restoration work in Crabtree is so important to us in our volunteer monitoring program. Things are happening with your data. Thank you very much.
Thank you, Susan. That was a wonderful presentation, and I think it will set up Chrissa's presentation really well. We have run over time a little bit, so what we're going to do is we're just going to readjust, and we'll go ahead and start our quick break. We'll all come back at 11 o'clock, and we'll give Chrissa the opportunity to present, and then I think at the end we will take questions for both of the presentations. So I hope that's okay with everybody. In the meantime, if you do have questions, please go ahead and put them in the chat, and we will see you all back here at 11. Thanks. Okay, welcome back. Hopefully people are coming back from their break. I hope you had a chance to get a drink of water, do whatever you gotta do, and come back. I'm gonna go ahead and introduce our special guest speaker. Chrissa Waite is an environmental scientist who is focused on managing coastal and environmental projects. She has worked for environmental consulting companies, the National Oceanic and Atmospheric Administration, and currently the U.S. Army Corps of Engineers in Charleston, South Carolina. And she is the project manager for the Crabtree Restoration project that she's going to talk about today. So Chrissa, welcome. We're happy to have you here, and take it away. Got you on mute.
There we go. I had to unmute in 2 places. So there we go. All right, I have shared my screen. Are y'all seeing that?
Yep, we've got it. Thank you.
Perfect. Okay. Well, Dr. Libes' presentation just a few moments ago was very illuminating to me. I knew about some of the water quality data and monitoring for this region, but learning a little bit more about it really brought to light, you know, kind of the importance of some of these restoration plans that we are working on. So I'm going to be talking to you a little bit today, a little bit about the restoration plans that are in the works for the Crabtree Swamp. And it sounds like you all know precisely where that is. We don't need to talk about that. For the next few moments while we're together, I'll be talking to you about, well, why would we even pursue restoration in the first place? I think Dr. Libes' presentation earlier made the reasons for that pretty clear. We'll also talk about some of the existing efforts that are and have taken place in the Crabtree waterway. I'll share with you a map of the project area, and then the meat of what we want to talk about today together is the plan for restoration, and finally the timeline. So the first thing we want to talk about is, why did the Army Corps of Engineers even pursue restoration of Crabtree Swamp? Well, as Dr. Libes mentioned, Crabtree Swamp, in its original form was a swamp, a wooded wetland. It was an unconfined, slow-flowing stream. It probably had a blend of herbaceous and woody vegetation that could withstand flooding for long periods of time. When there was little rainfall, portions of the swamp may have been dry. During periods of higher rainfall, the water would have the ability to spread out and fill a broad area and then slowly drain as the waters receded. And also, as we talked about, in Horry County, agriculture became a very important part of the economy. And this occurred in other parts of the United States around the same time as well. So there was a desire during that time to reduce the flooding, the seasonal flooding that would occur in the landscape, because it was better suited for crops. So that was kind of the driver for this channelization that we now see in Crabtree Swamp, and we've seen in many other waterways as well. As you all are probably very familiar, for the majority of the length of the Crabtree Swamp, Crabtree Canal, however you want to call it, the channel has been shaped and altered by humans, and it now has this very distinct trapezoidal shape. Well, of course, that trapezoidal shape is intended to convey water, right? It's like a chute where water just moves very rapidly through the system. Now, the problem with that is that it disconnects the main channel from the adjacent floodplains. And what this does from an ecosystem perspective is it reduces the diversity of plants and animals in the system. And I mean, it does what it was engineered to do, which is shoot water down the channel. Of course, the problem with shooting water down the channel is that we have a lot of erosion and sediment that is a result of this rapidly moving water. And so that results in the turbidity and some of the other challenges that Dr. Libes mentioned. So in channelizing this system, what we've done is create a system that is prone to bank failure, high sediment loads, very high velocity of water moving through it, water quality impairments, which you all are extremely familiar with, invasive vegetation, and just in general, habitat that is not really suitable for the aquatic flora and fauna that used to be present there, or would even like to be present there now. In 2014, Horry County sent the Charleston District of the Corps of Engineers a letter requesting assistance to explore ecological restoration of Crabtree Swamp. And in this letter, it specifically talked about the fact that the Crabtree Swamp was significantly modified and talked about all of these challenges associated with that, the high sediment loads, the channel velocity, the water quality impairments. So this letter requesting support is what stimulates the Army Corps of Engineers to, become interested in pursuing a project. So this kind of helps you understand why did the Corps of Engineers become involved. But there are a lot of existing efforts that have taken place in Crabtree Swamp as well. We'll talk a little bit about those. Between 2013 and 2019, there were a series of low-head rock weirs installed along the channel. And these were intended to do a few things. One was to provide stability in the channel to kind of prevent this cutting in of the channel and sedimentation that comes along with that. And also the rocks that the structure was built from provide some habitat for aquatic life. So little shelters, places of shelter beneath the rocks for invertebrates. It creates a little bit of pooling. So there's one example of the existing efforts. Another one was a stretch of floodplain bench that was installed between 2009 and 2012. This floodplain bench was designed to be inundated during a 2-year storm. It was planted with appropriate species like buttonbush, bald cypress, holly, and birch. And so what this floodplain bench does is it allows the water to spread out and slow down in times of peak rainfall. And of course, as you are all familiar with, extensive water quality monitoring efforts have been taking place in the Crabtree Swamp and adjacent waterways since the 1990s. So let's talk a little bit about the project area. Here we have a map of what was included in the project area. And it begins on the upstream end at Daniel Road, where you can see the red line on the left side of the screen, and goes all the way on the downstream end to Long Avenue. And so I'll kind of explain what we did in between those 2 points. So the part we're all interested in, what is the restoration plan? Well, let's talk about that. Overall, the intent of this project is to leave the Crabtree system more naturalized than what it is today, and build on those existing efforts that I mentioned a moment ago. The way that the Corps of Engineers is able to do this is through a program called CAP. And CAP stands for the Continuing Authorities Program. It has different sections under which the Corps can conduct work. And this project is under Section 206, which focuses on aquatic ecosystem restoration. It's really important to understand that since we are working under the specific authority, Section 206, we're only able to study restoration. A lot of projects in the Corps of Engineers focus on flood risk management, more of these built structures. I'm sure you guys have seen examples of these types of projects that the Corps of Engineers have done. But for this specific project, under Section 206, we're only permitted to study restoration measures. In this case, we came up with a series of objectives for the study. One is to increase connection to the floodplain, very important from a habitat perspective, to reduce sedimentation, to create more optimum habitat. That trapezoidal shape of the channel does not create, enough variety that appeals to a lot of species. And another objective was to eliminate barriers that prevent the passage of aquatic species. So knowing that those were the objectives, we went through a process of identifying a series of measures. And measures are just Army Corps language for what are the different ways we could achieve these objectives. And that planning process is pretty extensive. And what we ended up with were a series of 3 measures. And those are seen on the left side of the screen here. So the 3 measures that are included in this plan are berm breaching, making those connections back to the floodplain, installing log drop structures, and also installing some additional length of those floodplain benches. What we've done here in this image is show which of the objectives these measures help achieve. So here you can see that the berm breaching, in the lower reaches of Crabtree Swamp, there is a berm on either side of the waterway. And the idea is to breach that berm in a few key places to reconnect it to the existing wooded wetland on either side. This berm breaching also reduces sedimentation because it allows the water to spread out and slow down rather than just kind of shooting down the waterway. And when the water slows down, the sediment will drop off in those floodplains and then kind of you'll have less sediment in the main channel. And then also increasing optimum habitat. We're all probably familiar with the concept how floodplains provide nursery habitat and resting habitat for a lot of species. This second one, the log drop structure, helps achieve a couple of these objectives. One is reducing sedimentation. You can see in this diagram that's on the screen, the log drop structure, so there'll be a log that goes across the bottom of the channel, and it is keyed into each of the banks using riprap, and then vegetation is planted on either side to really secure that log drop structure into the bank. So this helps reduce sedimentation by, again, slowing down the water and really stabilizing the banks on either side of that log drop. It increases optimum habitat by creating some pooling effects just downstream of the structure and creating a little bit of that microhabitat for key species. And then finally, at the bottom, the floodplain bench. These floodplain benches were modeled after the benches that have already been installed in the system and have been proven to work very well. So they're designed, again, for a 2-year storm, And what they'll do is excavate down to a specific elevation on one side of the channel and plant that with appropriate vegetation. Very similar to the type of vegetation that has been planted in the existing benches. And again, this, what it does is recreates this connection with the floodplain to allow the water to slow down, reducing that sedimentation and increasing the optimum habitat. So one of the things that is very clear on this particular slide is that that fourth objective, there are no measures that meet that fourth objective. And so I definitely want to address that with you. For those of you who are familiar with the Crabtree Canal and its route through the city of Conway, you may recognize this specific location. It is where the Crabtree Canal passes beneath Highway 501. And you can see in this photograph is taken from the gas station that is located right there. The culverts have created a scouring effect downstream of the bridge. And under many conditions, there is a drop in the water level between the culvert and the surface of the water. And what this does is it prevents aquatic species during certain times of the year from being able to swim upstream. And so one of the objectives of this project was to identify a way to allow greater fish passage. And our team, consulted restoration experts. We went through a whole series of potential solutions for this area, for this fish passage challenge. And the measure that seemed most suitable is what we call a Newbury rock riffle structure. And what this is, it is using very large boulder in the center of the stream and kind of sloping downstream to raise the water level up enough so that that gap that you see in this photograph is covered by water. What we found was that there were a couple challenges that we found when we looked into this very carefully. One was that it would increase the flood stage at this location. So the water level at peak flood would be higher than it is today. Given the location of this area at this highway, knowing the flooding conditions that have been seen here in the past, the team did not think that was going to work. Additionally, the installation of the structure would only increase fish passage by about 45 days a year. So based on the risk and the expense of this specific measure, the team decided that it was not a good idea to move forward with it. So that is one objective that we were not able to address with this plan. I'd like to show you now a map of where these different structures are located in our plan. This first map is a stretch between, it starts at Daniel Road on the left side of the screen, and the bold blue lines represent the floodplain benches that are planned for this area. So a significant amount of floodplain bench is planned. When we began working with Horry County and some other folks in the area, one of the things that was emphasized is, hey, let's put in as much floodplain bench as possible. They really found that the benches that had been installed previously were doing what they were intended to do. And it was agreed upon that installing as much floodplain as possible would be helpful to this system. So you can see a significant amount of benching there. The sort of dark red or maroon line here is a place where bank stabilization has been installed. And then the two push pins are the existing low head rock weirs that I mentioned earlier. So looking at the next section, L Bethel Road to Highway 501, we have plans where the two purple push pins are to install a couple of those log drop structures there. They'll have a similar function to the low head rock weirs, but a slightly more natural type of material. And again, some additional floodplain benching there. Let me go back to this map. So you'll notice on the right side of the map, I don't know if you all can see my cursor. I think you can. On the right side of the map is that gas station we were just talking about the fish passage challenge there, where that gas station is. So between that gas station and Highway 701, there are no measures planned for this project. Now, there is existing floodplain bench in that stretch of Crabtree, so some of the challenges have been addressed in that area. So the next section of Crabtree Swamp that we're proposing to work in is between 701 and Long Avenue. So these bold white lines are where we're proposing to reconnect the floodplain by creating a gently sloping breach. These breaches will have, like I said, a gentle slope, and they'll be reinforced with a type of material, a geotextile material that can, if necessary, be driven over, can be used as a walking path. So accessibility should not be an issue during most times of year. One of the folks we worked with was Chris Herring. He's a restoration expert with the Corps of Engineers, and he was able to come to the site with us. He was able to walk the Crabtree Canal and see what the conditions are now and help us really envision what we might be able to do in the system. And one of the things that he said is quoted here on the screen: this could be the poster child for engineering with nature. And the reason that he said that is we're planning to use as natural a material as we can. So the floodplain benching kind of recreates the type of floodplain, you know, a more natural floodplain. The log drop structures we're trying to use more natural materials for that. The berm breaching, we are using some geotextile materials for durability, but really just trying to work with what the system, quote, wants to do. And a really important piece of this is how we, or the Horry County or the City of Conway, maintain the system after these measures are installed. So let's talk about that next. So maintenance is going to be a very important part of the success of this project. When the Corps of Engineers does projects, we can only work on land that has certain types of easements on it. And because this is a restoration project, there's a specific restoration easement that the Corps uses for that. And the easement dictates limitations to how this land can be used after the project is complete. So I just pulled a little bit of the language out of this easement. And what you can see is areas where the restoration is occurring, you can not do any mowing, removal of vegetation, spraying of vegetation. That vegetation is intended to stay in place and grow naturally. Also, it talks about how you cannot build any permanent structures in the area or impede the channel and things like this. And so this is going to be a really key part of the success of this project, and I believe the improvement of the ecosystem along Crabtree and the water quality, which I know is what you guys are very interested in. If you have vegetated buffers on either side of a stream, you're going to be capturing a lot of the surface runoff that is coming into the stream. So the more that we can promote this natural vegetation growing on the banks of Crabtree, the more we're going to kind of capture naturally. Also, what we found is when you look at portions of Crabtree Swamp, there are small sections of it that when they're left alone, you can see channels, small channels forming within the bed of the main channel. So what that is during periods of low flow, you'll have this little meandering channel in the center of it. And then if you get a rainfall event, you get a slightly broader channel forming. And this is what waterways are supposed to, how they're supposed to behave. And then by installing these floodplains, we're giving the water space to go rather than just kind of shooting down a tube, you know, which is kind of what it does now. So, you know, we really believe that this maintenance, the way that the channel is maintained after the project, is going to be a very key part of not only improving the habitat and the ecosystem, but also the water quality issues that I know you are very interested in. So just to give you guys kind of a sense of where we are and where we're going with this, what comes out of this study that we've been working on is what we call a feasibility report. How feasible is it to restore Crabtree Swamp? What are the benefits we're going to get? So the Corps of Engineers puts together a significant report looking at all the aspects of this restoration. And we're hoping to send that to our division office in Atlanta by the end of this calendar year. And then so long as the Corps is on board and Horry County is on board and the city of Conway is on board, then, you know, if we can get all those folks together and everybody feels like it's appropriate to continue, then we'll initiate what we call the design and implementation phase. And what that will do is allow us to do final engineering plans and specs, and then move into contracting and construction of this project. So that's kind of where we are and where we're going. And that is the end of my presentation.
Thank you, Chrissa. That was really excellent. And I think our volunteers and our other attendees are probably really excited to hear all the cool things that are going on in Crabtree right now. Right now, we would like to open it up to our participants to ask some questions of our presenters. If you would like to speak, we can unmute you. If you just want to kind of clap your hands at us down in the reactions, if you see down where the chat is in your control bar, there's also a little thing that has a little smiley face, says reactions. So it doesn't have a hand raising one, but you can kind of catch our attention if you want to ask some questions. So anybody with questions? You can also put your questions in the chat.
I hopefully have changed the permission so people can unmute themselves if they have a question.
Awesome.
We'll see if that worked though.
I know somebody has to have questions. Nobody?
Well, I don't have a question, but this is Chelsea Gagliano with Horry County Stormwater. I just want to say thank you, Chrissa. That was excellent. You know, we're just trying to wait for the necessary people within our department to basically get the ball rolling on this. If everybody was wondering where we were at with that, you know, it's COVID-19 and we're struggling right now to try to get everybody on the same page with the project, but it is coming. Hopefully we can get something soon with it. And again, I just wanted to thank all the volunteers for the extremely hard work y'all have done, especially throughout these times. And I think that the communications that we have had throughout this year have been really great. You guys, you know, you're the front lines out there, and you find, you know, if you see illicit discharge or anything like that, you know, you've got that information to Dr. Libes or Victoria or whomever, and they've got it to me. And there have been a few instances where I've responded to those calls, and I just wanted to say thank you guys for all your hard work. So.
Thanks, Chelsea. Chelsea, do you want to quickly introduce yourself? I know that some of our volunteers and attendees know you, but you might be like, who is this disembodied voice thanking me?
Yes, I can put my video on too.
Don't have to.
Here we go. Hello. I am the watershed planner for Horry County Stormwater. I have been with the county for a little over a year and a half now. I came from SCDHEC working with septic tanks for about 2 years before I came to the county. And before that, I did fishery observing with independently contracted through NOAA. So I'm kind of sticking to the conservation route. I love my job, and again, just wanted to introduce myself and thank you guys for all your work.
Thank you, Chelsea. We're happy to have you and glad you're doing really great work with Horry County Stormwater.
Thank you.
Okay. Do we have any questions from anyone else? Well, actual questions.
If not, I'll say a few words of thanks to Horry County, not only for their continued support of the volunteer monitoring program, but for being so innovative to have established a watershed manager position way back in the day. So when Chelsea stepped in, she was taking over from someone who had done a fantastic job, and I think really made the restoration work at Crabtree possible. So kudos to Horry County for being on the cutting edge of innovation here in terms of water quality and biological diversity. They've just been championing this every step of the way, and I feel really fortunate that I ended up in a community that had such forward-thinking stormwater management.
Yeah, thanks. And I feel very fortunate as well because, you know, I kind of stepped into this role and a lot of projects were thrown at me and said, here you go. The last guy who had the job left some notes and you figure it out. I'm like, okay, I got it. So yes, thank you for everyone's support. You know, I still figure new things out daily. So.
I would echo that. The Corps of Engineers has a chance to work with a lot of different municipalities, counties, states, and I have found that Horry County is excellent to work with. They're on the ball, they're forward thinking, and I'm just very impressed that they, you know, explore all of the options that are out there for improving the resources in Horry County. So definitely 2 thumbs up to y'all.
Right, and I'll make one more pitch here that I know this is appreciated downstream. So City of Conway works very closely with Horry County on these stormwater issues, but Georgetown County is getting the benefit of all of this great stormwater management as they're the recipients of what we're sending downstream to them. So I know they very much appreciate this, including all the efforts of the volunteers to monitor downstream.
I think that was part of the point we were trying to make earlier with our slide showing all of the organizations and groups that are involved with this monitoring program. It's a watershed, so it's a watershed approach to what we do, and I think that's really important. And I'm I'm lucky to be a part of it. One thing that I wanted to do earlier that we kind of skimmed over, I'd love to give our volunteer monitoring coordinator and assistant coordinator the opportunity to just introduce themselves and say hi to you volunteers. So Kelly and Victoria, I don't know who wants to go first. Kelly's probably cursing me for putting her on the spot, but I know how much the volunteers love you, so I'm sure they would love to hear from you.
Hi, everyone.
Hi, everybody. I'm Kelly Hall, and I am one of the volunteer monitoring coordinators, if you haven't met me yet, alongside with Victoria. And I have been filling in as much as I can with this COVID. I've been doing 3 of our sites, Conway, Pitch, and Bucksport, since all of this started. I'm glad to have everybody back and volunteering with us. It takes a lot of slack off of us too, which is great. We can get reports done and get everything out to you and to everyone else that we need to. And it's just great that you all tuned in today, and thank you so much for everything that you do.
Yeah, and to echo what Kelly said, I'm Victoria Green, the volunteer monitoring coordinator. And we do appreciate all of the hard work of our volunteers. It is crazy times, and the fact that we are still able to continue our mission of volunteer monitoring, of keeping an eye on our watershed, and our very big watershed, we're really proud of that. So we'll have some updates to give. I guess I can go ahead and do that now, Kara. Just some quick updates. So normally during these data conferences, we would have a lengthier presentation telling you little tidbits and tricks about volunteer monitoring and the procedures, little things we've discovered and the science throughout the year. But this year, we have a lot of things to update. So let me share my screen, excuse me. We will be doing that in its own separate event. And I'm hoping, it looks like you can see my screen now. Yeah.
Yeah, we can see it.
Looks good.
Thank you. So first was our big thanks to everyone. The amount of communication we've had with our volunteers this past year has increased exponentially, and we really appreciate that open communication with us, telling us whether you can't make it, you can make it, you're still there, even if you can't join us in person. And to all of our volunteers who are still out there being safe and collecting this data, we appreciate you. So we're really excited to debut this handbook. We will be delivering it in December and January. We are putting the final touches on it now. And I know you've likely heard me talk about this for a very long time, but we did a lot of improvements and updates and making sure that we're doing the very best volunteer science that we can. And so we will be, those will be our end of the year gifts to you all, is this new handbook. In January and February, we will figure out a way for us to reconvene and to train and do science together. We'll have these virtually retraining sessions, and we'll try to make them as interactive as possible as we make sure all of our volunteers are on the same page. So we are very excited about that, and that will be happening in the next couple of months. I can't believe December is next month. For those of you who know Zachary Lovelace, he might have assisted you out in the field a couple times, especially for our Merle's Inlet program. He just successfully defended his master's. So if you see him out in our watershed, give him a good congratulations, and we are sure he will be doing more citizen science and water quality work in the future. And this is our contact information. If you've been paying attention to our emails, we've been calling ourselves the Volt, because in these times we really wanted a fun acronym to refer to ourselves as. So we're the Volunteer Operations and Logistics Team. We'll get a cool lightning bolt logo at some point, but this is us, and if you need to contact us, please do. We we'll try to answer your concerns, and if we can't, we'll pass them on to someone who can. So our big updates will happen in January and February, and we encourage you to stay connected with us on our Facebook page and also our new newsletter, which has a lot of great information about everything that we're doing. So that was my quick overview from the Watershed Academy.
Thank you, Victoria. That was great. And thank you, Kelly, for jumping on and saying hi. I have just been informed that I still owe you all cookies, even though we are virtual. So I'll have to figure out how I'm going to manage that one. But I would like to take that opportunity to say that, you know, this has been really wonderful, and we're glad so many of you can join us. But we do miss you. We love having the volunteer luncheon and the data conference because it gives us an opportunity to see all of you when we might not see you throughout the rest of the year. So we miss you. We cannot tell you how much we appreciate you doing all your hard work, and that goes for the volunteers, our staff, our supporters who are joining us today, basically anybody who loves and cares about the Waccamaw and our coastal Waccamaw watershed. So thank you all so much for joining us. We will send a follow-up email to thank you for joining us, and we'll include those contacts for you. So if you have any questions that maybe you didn't want to ask today or something that you think about later, you can feel free to contact any of us. And like Victoria said, we'll do our best to answer it. And if we can't, we'll send it to somebody who can.
Can I just jump in here before we sign off? As Kelly mentioned, we're short on volunteers for Team 3. Victoria or Kara, if you could just speak to what we need there.
Sure, we'd be happy to. We do have a couple teams that need volunteers. So if you are interested in volunteering, if you're not already, or if you know someone who is, please put them in touch with us. Those of you who know what volunteering entails can kind of give that information, but we provide all the training, all the materials, all the supplies that you'll need, as well as technical support and coordination. So it's a 2 morning a month commitment, as well as some training, but we could use some help out on the river. So if you're interested, let us know. The one team that particularly needs help right now is Team 3, which samples at Conway Marina, Pitch Landing, and Bucksport Landing. We will also need help in Georgetown in the coming months. So let us know if you're interested. And if those sites don't work out for you, we do have other teams, and they're often happy to have new people join them. Although we have been limiting how many people can go out right now due to COVID concerns, but we always need backups. We always need help. So if there's anything you're interested in helping out with, please feel free to contact us. And please feel free to share that information with your friends and family. Our website, www.winyahrivers.org, has a flyer posted and some other information about volunteers and what you would be doing and who you can contact. But you can contact me, Victoria, Kelly, any of your Volt team. So we're always happy to hear from you. All right. Anything else I have forgotten, Volt people? All right. Well, once again, thank you all so much for joining us. We really enjoyed having you. This was a great meeting. I think we had 2 wonderful presentations. This will be posted online in the next week or so. And stay tuned for more cool stuff coming from the Waccamaw Watershed Academy and the Waccamaw River Keeper. Thank you all for joining us. Have a great day and a great week. Thank you.
Thank you, Chrissa.
Thanks for having me. Thank you.